So you mouse click on this, just like a button, and something happens over here. So it's obviously a user interface.
But it's right there in the editor window. Besides, it looks like a document.
So what? It has behavior. It can pop up a menu or change its own appearance to provide feedback. The buttons work together like a control panel, so it's an interface.
Yeah, but you can edit and format the whole thing just like text or graphics. That makes it a document.
No, it's used to control other applications. It's a control panel. It's a user interface.
The document tools all work in it, and I can mail the result. It's a document.
It's an interface.
It's a document.
Interface.
Document!
Wait! They're both right. It's an interface and a document.
You are looking at the screen of a Sun Microsystems SPARC station running the Cedar programming environment. In the left column of the display are two editor windows. The top window is managed by the Tioga text editor and the bottom window by the Gargoyle graphics editor. This video will demonstrate how documents managed by these two editors can act in several different ways as user interfaces. Tioga is a WYSIWYG editor for structured documents. It can edit and display sequences of characters with different typefaces, sizes, and other appearance attributes. In this document, several of the paragraphs are buttons that change appearance when pressed. Gargoyle is a direct manipulation editor for two-dimensional graphical objects. Gargoyle objects can be made from lines, curves, text, and scanned images. During interactive editing, these objects attract the cursor, allowing users to easily select or snap to objects. In this picture, several of the objects are buttons that change font and dash pattern when pressed. Here is a toy graphics application. Shapes can be created by clicking in this drawing area. Using the control panel, we can alter the shape mode, change the line thickness used for new shapes, or erase. This control panel is actually a Tioga text document. The erase button is a pop-up button. It displays a menu of two options. The stroke with button is a multi-state button. It cycles through a set of numbers. The shape buttons are a set of radio buttons. Like the buttons on a car radio, only one of these can be on at a time. Because this control panel is a normal Tioga document, I can change its text, font, and layout using familiar text editor commands. This second window is running the same toy graphics application. This time, the control panel is a Gargoyle picture. The graphics application does not know which control panel it is using. The Gargoyle control panel uses graphical feedback to show changes in shape mode or stroke width. I can edit this control panel using familiar Gargoyle editor commands. I can save the modified control panel for future use. Not only are document control panels easy to edit, but they are easy to copy. If I want to suggest an improvement for the control panel to the application's designer, I can copy the control panel into a message and mail it. There are many ways to create embedded buttons. In this text document, special buttons called buttonizers can be used to turn other document objects into buttons. The first buttonizer makes an on-off button. The second one makes radio buttons. And the third one makes a pop-up button that offers a choice of colors. Buttonizers can also be used to create buttons in illustrations. For example, this circle can become a button that offers a choice of colors. This star can become a button that changes its own color. These three arrows can become a set of radio buttons, only one of which is black at a time. It is possible to edit an existing button to achieve new behavior. In this example, the button pops up a menu that contains entries labeled red and green. In Tioga, we can expand text in place to view and edit its hidden properties. Button behavior is described in a property called button data. Here we add an additional option, blue, to the button data and then try out our modified menu. Our buttons use ordinary document editing operations to display feedback when pressed. For instance, these buttons in the Tioga text editor can change from black on white to white on black, from plain face to bold face, from clear text to struck through text, from small size to large size, or from one wording to another. This paragraph is a button that takes up several lines. It changes its font and rejustifies itself when pressed. In the Gargoyle graphics editor, buttons can use graphical editing operations to display feedback. For instance, when we click on this electrical switch, it repositions its parts. This button changes color. And this button changes both its shape and label. Because buttons are represented as document properties, they can easily be generated by programs. Here we use a directory listing program that creates a button for each subdirectory or file listed. Clicking on a subdirectory button generates another buttoned list of that subdirectory's contents. Clicking on a file name button opens the named file. Some Cedar programs parse text documents. This document allows users to customize the Gargoyle editor by changing values in named fields. These values are buttons. Clicking on this one changes it from true to false. This other one gives the user a choice of typefaces. Selecting in the menu causes the displayed value to change. Gargoyle can now reparse this file and begin to use the new options. We can use document operations to find and create buttons. This Tioga document contains many examples of buttons organized into sections. I can view just the headers of these sections to find the one I want, and then drop down into that section to try out the buttons found there. I can also find buttons using textual search. For instance, if I search for the word guava, I find a multi-state button. This button cycles through the names of fruit when pressed. Using a tool that searches for text patterns and applies properties, we can make many buttons at once. In my address book, I can search for phone number patterns and apply button properties to each phone number, producing a set of buttons that dial the phone when pressed. By turning document objects into buttons, we can effectively change the user interface of a document editor. For example, if I want to proofread this document and line through unwanted words, I can turn all words into buttons that draw a strikeout line when they are clicked. In Gargoyle, these shapes are two-state buttons that change color when clicked. I can experiment with different colorings for a while and then turn off button activity to edit the resulting shapes normally. Likewise, in this Gargoyle scene, the line segments transfer their dash pattern or stroke width to other selected Gargoyle objects. Artists can use embedded buttons to build palettes of frequently used elements of graphical style. Because Gargoyle objects attract the cursor when it comes near them, users can easily press these narrow buttons. In summary, buttons can be embedded in different media, including text and graphics. Documents can be used as application control panels. Buttons can be created using buttonizer buttons or by editing strings in the button language. Buttons can take advantage of editor operations to highlight themselves when pressed. Buttons can be created and read by programs. Buttons can be found and created rapidly using document tools. And buttons can be used to customize the behavior of document editors. Because the Documents as User Interfaces architecture is independent of any particular editor, it will extend to new media and new editors.